Today we are discussing one very important topic of design and analysis of algorithm. In dynamic programming, we do the longest common subsequence identification. Okay, so first we need to know what is a subsequence. So consider a sequence S1 here is say A, B, C, B, A, C, B is a string. Okay, now any substring of S1, say I am representing it by SS1, is a sequence by deleting some of the alphabets or none of the alphabets. So this whole is also its own subsequence, as well as if I say delete some of the alphabets and I copy the remaining, this is say one of the subsequence of this sequence. Okay, so the idea is to find the, so if we have two sequences here, say S1, and I have another sequence here, say S2 is equals to say A, C, C, B, A. Okay, so maybe B, B, A. Okay, so if this is a sequence, so these are two sequences, we need to identify the longest possible common subsequence. So if I say directly, so say AC, this is one of the common subsequence. You can get AC by deleting rest of the element, and you can get AC here also by deleting rest of the elements. So AC is a common subsequence. Now the idea is to find the longest common subsequence between these two sequences. Okay, so let's see how we do it. So we are creating this matrix here, say longest common subsequence is equals to, okay, and suppose the length of this is say M, length of this is say N. We are creating a matrix of size M and number of columns are N. Okay, so here if we see these are 1, 2, 3, 4, 5, 6, 7. So my M is equals to 7 here, so I write like M is equals to 7, and if I say 1, 6, so N is equals to 6. So let's make this matrix 1, 2, 3, 4, 5, 6 and 7. Okay, and one additional I am taking, so the size here I am considering is 6 plus 1 and 7 plus 1. Okay, so M is 7, the size I am taking is M plus 1. Here I am taking N plus 1. Okay, so this is say first, second, third, fourth, fifth, sixth and seventh. Okay, so these additional when M is equals to 0 or N is equals to 0. Okay, so that is being filled at 0. Okay. So now what is the meaning of any index I comma j here? Okay, so the meaning of LCS I j, okay, means when you have say in string S1 you have elements from x1, x2 till xi, okay, and you are ignoring all the other elements, you are just considering this subpart of this string, and when in your S2 you have elements from y1, y2 till yj. So in these substring, what is the longest common subsequence? So idea is to identify a small subproblem, and then by using the solution of subproblems we are trying to identifying the solution of bigger subproblem. So if I say at a particular position, okay, ij, what is the possibility? So the possibility is that either S1i is equals to S2j. I mean either these alphabets if I write, so let me write the alphabet first, A, B, C, B, A, CB. Okay, so I'm writing here A, C, B. Okay, and the alphabets on the top are A, C, C, B, B, A. Okay, so one possibility is that these two elements are same, as in now in this condition this is C and this is C. So as 1I is equals to C, this is also equals to C. So if these two statements are equal, then my solution will be, so my LCS, in this case my LCS I comma j will be equals to LCS of I minus 1 comma j minus 1 plus 1. Okay, so why this? Because whatever we have the solution by without these two alphabets. Okay, now we have one more match here, so the previous longest common subsequence plus 1, that is for this. So this will give me the length of the longest common subsequence. Okay, so you can stop this part here, then